Good morning, everyone. So for the first example, we have here a 14,300 kilogram airplane is flying at an altitude of 497 meters at a speed of 214 kilometers per hour. So we are just to determine the airplane's total mechanical energy. Okay, so recall that the total mechanical energy of a system is just obtained by adding all the kinetic energy and all the potential energies that are present in the system. So here we have an airplane that is at a certain altitude or at a certain height equal to 497 meters, and it is moving with a speed equal to 214 kilometers per hour. Okay, so here we have two components of the mechanical energy. The first one is the kinetic energy, since uh it is moving. So nasa kinetic energy, and then it also has the gravitational potential energy. Okay, so we just have to add the two. So the total mechanical energy is equal to GPE plus kinetic energy. And then we note that GPE is equal to mass times the acceleration due to gravity times the height. And then kinetic energy is equal to 1/2 mv squared. So since we are given with the mass, we are also given with the height as well as the velocity, then we just have to substitute all to our equation. So we have this one. 14,300 kilograms multiplied by 9.8 meters per second squared multiplied by the height or the altitude plus 1/2 times the mass times take note class that since the speed is given in kilometers per hour, we need to convert this to standard units of speed, which is in meters per second. So converting 214 kilometers per hour, we will get 59.44 meters per second. Okay, so using your calculator, you can get this one. So it has a very huge total mechanical energy. It's 94,986,191 joules. Okay. We can also express this in scientific notation. So we have 9.5 times 10 to the 7 joules. Okay. So far, straightforward lang nga solution for problem number 1. All right, so let's proceed to the second problem. So a kid is sitting on a toboggan at the top of a 23.7-meter tall hill. So if the kid and toboggan have a total mass of 37.3 kilograms, determine how fast they will go when they reach the bottom of the hill. Okay, so assume that there is no friction. All right, so we have here a system. Now, take note that energy cannot be created nor destroyed. It can only transform from one form to another. Okay, so here initially, the kid is sitting on a toboggan and it is at rest at this particular point. Okay, and then it slides down the hill, of course, with a speed. So as it goes down, the speed increases and the maximum speed is attained just before it hits the ground. Okay? So at this point, na siya sa ground, um, naa siya particular or diri ma-attain ang maximum speed, but since wala na siya height with respect to the ground, then the gravitational potential energy at this point is equal to 0. Okay, so again, at this point, this is where the maximum gravitational potential energy is attained, and then diri 0 ang gravitational potential energy. So unsay nahitabo sa gravitational potential energy, it will be converted totally into kinetic energy just before it hits the ground. Okay, so we are given with a total mass of the kid and the toboggan. So it is equal to 37.3 kilograms. And then we are also given with the height of the hill. Okay, so here we will use the conservation of energy principle. So it states that the initial or the energy before is just the total energy before is just equal to the total energy final. Okay? Or so kini siya iyang right hand side of the equation is the final total mechanical energy, and then the right hand side of the equation is the total um, initial mechanical energy, but it really doesn't matter kay equal naman sila kas no bisag asa ni siya kung ano siya sa right hand side or sa left hand side, it won't matter. Okay, so we have for the final kinetic for the final total mechanical energy, we only have the kinetic energy. So at this point, the energy that is present here is the kinetic energy, while sa initial, the total mechanical energy is composed only of the gravitational potential energy because, again, we started off from rest. Okay? So, we have 1/2 mv squared is equal to mgh. So, the mass won't matter here. So, it will cancel out. And then since v is our target variable, then we will isolate v. So you have v squared is equal to 2gh. Okay, and then we have here v is equal to the square root of 2gh. Substituting the height. So ang height lang man ani ang dili constant. So you have square root of 2 times 9.8 multiplied by the height, which is 23.7 meters. Okay, so the maximum speed attained by the kid and the toboggan is equal to 21.55 meters per second. So this example illustrates, yes. So this example illustrates conservation of energy since wala man po yung frictional force, no? Assume there is no friction. So energy is conserved at this in this example. So you have kinetic energy equals 0 initially, while GPE is equal to mgh, and then at the final state, you have kinetic energy equals 1/2 mv squared, while GPE is equal to 0. Okay? So we can actually extend this to kanang na kay roller coaster nga track, for example. So that is magnindot kay mag-calculate og total mechanical energy sa roller coaster class. Okay. So we have the third example. So we have Wiley Coyote is trying to drop a 10-kilogram boulder off a 10-meter high cliff to hit the roadrunner. Okay, to hit the roadrunner eating a bowl of birdseed on the road below. So we have this not so good drawing. So this is where Wiley Coyote is. And then this is the boulder, 10-kilogram boulder. This is the cliff, and then I think this is where the roadrunner is. Okay, so the roadrunner is eating a bowl of birdseed on the road below. At this particular location, the gravitational acceleration is 10 newtons per kilogram or 10 meters per second squared. So he wants to know the speed of the boulder at various points above the road. So how do we solve this one? We can actually solve this if we are given with the time. Okay? So kung ang time ang given, we can actually solve this using one of the 4 kinematics equations. So this one. So V, the final velocity, is equal to V naught minus GT. But time is not given, so we will use the conservation of energy principle to calculate the speed. So aside from, diba, we have tried using the dynamics equations as well as the kinematics equations to solve for the velocity. So aside from that, we can also use the conservation of energy principle. Okay, so this is a free fall problem, but we can also solve this using the conservation of energy principle. So what are given? So we are given with the mass of the boulder. We are also given with the height. So we can get the initial gravitational potential energy. Okay, so at this particular point wherein Wile E. Coyote is holding the boulder here, so the boulder has a gravitational potential energy that is equal to mgh. So you can get the initial gravitational potential energy. You have the mass times the acceleration due to gravity, which is specified to be equal to 10 meters per second squared. And then multiplied by the height of the cliff, so which is equal to 10 meters also. So you have 10 cube, or 10 times 10 times 10, so that is equivalent to 1000 joules. Okay, so initially you have, or this boulder has 1000 joules of gravitational potential energy. Okay, so this is for letter A, we want to know the speed at 10 meters. Okay, so basically 10 meters, kaya na pa siya diri, no? Wala pa siya na-drop. So the speed is equal to 0. So that is a given. So kinetic energy here is equal to 0 because the speed at this point, at this particular point, is equal to 0. Now, how about at 8 meters? Okay, so at 8 meters, the boulder is starting to speed up, or nana siya speed class at 8 meters. Okay, so during a point, aning a point, we want to know the speed of the boulder. Okay, so since the height of the boulder with respect to the ground decreases, that means mugamay po iya ang gravitational potential energy. Okay, so at this particular point, naa na siya kinetic energy. Now, take note that the total mechanical energy before is just equal to the total mechanical energy after. So initially, naa siya 1000 joules of energy. And then diri, kung i-add up na to ang gravitational potential energy and the kinetic energy, it would sum up to katong sa initial 1000 joules. Okay? So let us try to get first the gravitational potential energy at this point. So it is equal to mgh, where h is equal to 8 meters now. So substituting, we will get 800 joules. Okay? And then, noting that ET, or the total mechanical energy at this point, is just equal to the sum of the kinetic energy and the gravitational potential energy, then we can get the kinetic energy. Okay, so the kinetic energy is equal to ET, the total mechanical energy, minus the gravitational potential energy. So this is just simple subtraction. So you have kinetic energy is equal to 200 joules. Okay, now that we have the kinetic energy, we can then get the speed. So this is our target variable. So the speed is equal to 2 ke over m raised to the power of 1/2. Or this is equal to the square root of 2 ke over m. Okay, so 1/2 here, this 1/2 ng factor here is just equivalent to taking the square root of this term here. Okay, so you have 2 times 200 joules divided by 10 kilograms. So you will get 400 divided by 10. Pila na siya class? 40. Okay, so square root of 40, you will get 6.32 meters per second. So you can verify this using your calculator basta wrong na itong solution. Or wrong na itong calculation. Okay, so at this particular point, the velocity or the speed of the boulder is equal to 6.32 meters per second. Now, how about at this point? 3 meters. So, naana siya diri, 3 meters. So, again, pwede gihapon na to kwaon una ang GPE. So, you have 10 times 10 times 3. So, mass times the acceleration due to gravity multiplied by 3. So, you have 300 joules. And then subtract this with the total mechanical energy, which is 1,000. So, you have 1,000 minus 300. So we will get kinetic energy equals 700 joules. So as you can see, as the boulder is going downwards on the cliff, the kinetic energy increases. Okay? So kaganina, ayan, kinetic energy, nag-start siya 0. And then at 8 meters, nahimo siyang 200 joules. And 3 meters na lang from the ground, kaya nahimo na siyang 700 joules. Okay? So as the boulder goes down, the kinetic energy increases, but the gravitational potential energy decreases. Okay, so we have now the kinetic energy. So we will then use the same equation to find for the speed. So we have V is equal to the square root of 2ke over m. So substituting, we will get 11.83 meters per second. All right. So this is at 3 meters. Now, just before it hits the ground, the gravitational potential energy is equal to 0. Okay, so 10 times 10 times 0, you will get 0. The gravitational potential energy is completely converted to kinetic energy. So the kinetic energy is now equal to 1,000 joules. So V is equal to the square root of 2 times the kinetic energy divided by the mass. So this is equal to 14.14 meters per second. So this is the maximum velocity attained by the boulder before it hits the ground. Okay? So do you have questions?
Answer for now.
Okay. So this is another example of
Then, ma'am.
conservation of energy. All right, so let us continue with the fourth example. So we have a pendulum. Basically, a pendulum is just a mass connected to a string. Okay, so a pendulum is pulled aside and then released as shown in the illustration. So determine its speed at the bottom of the swing. So ato siyang gibira padulong diri. And then gi-release. So initially, it is 13 centimeters with respect to the ground. And then gi-release siya na to. Okay, so balik-balik kayo na sa class. Okay, so our goal is to find the speed at the bottom of the swing. So at this point. Okay, so again, we will use conservation of energy. So initially, naa siya GPE. And then at this point, naa siya kinetic energy. Wala siya GPE because this is where the ground is. So, muna siya itong gina-consider nga ground. Alright, so it is lifted 13 centimeters from the ground. So, at this point, it is lifted 13 centimeters from the ground. Convert that to meter. So, we will get 0.13 meter. So, first, we have mgh equals 1/2 mv squared. So canceling out m. So as you can see, we are not given with the mass because cancel out the gihapon siya class. So we have this equation. So V is equal to the square root of 2gh. Actually, this is a very familiar equation. Makuha gihapon ni siya ninyo class sa kinematics equation katong V final squared equals V initial squared minus 2gy minus y naught. Okay, so it is the same as this one. Mawala lang siya initial velocity. Okay, so V is equal to the square root of 2gh. And then substituting, we are given with the height. So converting lang this to meters. So we will get 2 times 9.8 meters per second squared multiplied by 0.13 or 13 times 10 to the minus 2 meter. Okay, so we have speed is equal to 1.6 meters per second. So see how this whole conservation of energy principle gives us a very simple solution in finding the velocity. So, di ba, niagi tag kinematics equation, naghan pa kaing pangitaon, but this time, the conservation of energy principle allows us to calculate speed very simply. Okay? So, it's the end of the discussion. Okay, so any questions, class? Okay, so we have 33 minutes to discuss momentum and impulse. Okay, somehow we have murag na may idea kung unsa ning kung anong momentum. Okay, so what happens during collision? Okay, so there are problems also that cannot be described completely using Newton's law. So katong di ba natay F equals ma. Okay. So certain problems cannot be completely described by Newton's laws. So we will use momentum and impulse to describe this particular cases, mga collisions. Okay? The fifth chapter is conservation of momentum and energy in collisions. Okay, so let us define first linear momentum. So linear momentum is a vector quantity which is denoted by the small letter p or the lowercase letter p. Okay, so it is defined as the tendency of a moving body to continue moving and the difficulty it encounters in slowing down to rest. Okay, so asa pa ni nato madungganing momentum. So kasagara kay sa mga sports like basketball for example. So a person or an object that has a great momentum is difficult to stop. Okay? So kung naa kay object nga dako kaayog amount of momentum, lisod na siya stop. Okay? So it is the tendency of a moving object to continue moving and the difficulty it encounters in slowing down to rest. Okay, so mathematically, momentum can be expressed as the product of the mass and the velocity of that object. Okay, so mass times velocity, that is equal to momentum. So its SI unit is kilograms meters per second. So kilogram meter per second is the SI unit of momentum. And then it takes the direction of the velocity. So if the velocity is directed to the left, then momentum is also directed to the left. If velocity is directed northward, then momentum is also directed northward. So it takes the direction of the velocity of the object. Now, by components, we have this one. So the x component of momentum is just equal to m times v sub x, the y component, and then the c component. Now, since the acceleration is equal to the change in velocity with respect to time, then Newton's second law can be written as this. So you start off with F equals ma. This is Newton's second law of motion. And then acceleration can be defined as the change in velocity with respect to time. And then we can take this out. So you have, or pwede na siya na ito ipasulod sa derivative nga sign, total derivative nga sign. So you have d dt, or the derivative of mass times velocity with respect to time. This is equal to the change in momentum with respect to time. So we have another definition for force, which is the change in momentum with respect to time. So you have this one. So another definition of the Newton's second law, it can be stated as the net force acting on a body is equal to the time rate of change of momentum of the body. Okay? So we have another definition of Newton's second law here. So this is familiar. We have discussed this in our dynamics class. So we have here another definition of Newton's second law. Okay, so mathematically you have this one. So these are equal. So MA is just equal to dP over dt, or the time rate of change of momentum with respect to time. Now we have another physical quantity here, impulse, which is denoted by J. So impulse is the product of the net force and time interval. Okay, so balik ta din, no? So if you multiply this with time, so kini siya, if you multiply this with dt, or if you multiply both sides by dt, you will get impulse. Okay, so as you can see here, force, the net force multiplied by the time interval is just equal to the change in momentum. Okay, so we can define also, so again, impulse is defined as the product of the net force and time interval. So J is equal to F times delta T. So it is an impelling force that acts suddenly and produces motion. So impulse. It is the account of the force and how sudden that force acts on a particular object. So, like for example, if masumbagan ka ni Manny Pacquiao, ang ang sumbag kay grabe ka sudden, pinakalit, or gamay ra kaayo ang ang time nga ni contact siya sa imo ang face, impulse, or the amount of force nga imo ang ma-experience is very huge. Okay? Whereas kung imong i-ride ang punch, like for example, nisumbag siya, tapos imo ang gilikay ang imo ang face, imong gi-ride ang punch ang tawag ana. So the time of contact increases, thereby decreasing the force. Okay? So mas dili ra ka ito siya sakit compared atong imong gitagbo ang iyaang punch. Okay, so the SI unit of impulse is Newton second. So you have Newton from force and then second from time. Or this is also equal to kilogram meters per second. So these two units are equal. So nakay Newton second, 1 Newton second is equal to 1 kilogram meter per second. Okay, now, again, balik ta dito sa previous slide. So here we can see that when you multiply both sides with delta t, or the time interval dt, so this is the impulse, J, and then kini siya, makancel out maning dt, so we have the change in momentum. dp is the change in momentum. So J is also defined as the change in momentum. So when we say change in momentum, that means we have to account for the final momentum and the initial momentum. So P final minus P initial, that is equivalent to the impulse. Okay? So for example, if you want to know the impulse and you are given with the force as well as the time, then you can use this equation. But if you are only given with the mass and the velocity initial and final, then you can get the momentum initial and momentum final and get the impulse. Okay, so this is the impulse momentum theorem. So this equation basically is the impulse momentum theorem, which states that the change in momentum of a body during a time interval is equal to the net force that acts on the body during the time interval. So if you were in a car that was out of control and had to choose between hitting a haystack or a concrete wall, so asa man ka mamili, class?
Haystack man.
Okay. So bisag dili ka physicist or bisag wala kay knowledge sa momentum impulse, of course, you should choose the haystack, no? But here is the reason why. The same velocity, for example, the same car, no? Out of control nga car, the same mass. Okay. Now, the haystack will give us gamay nga impact compared to a concrete wall. So the same with katong punch ni Manny Pacquiao, kung imo siyang tagbuon o imo siyang i-ride the punch. So ang mag-change actually, class, is the time of contact. So here, using the haystack or with the haystack, the time of contact increases, thereby decreasing the force. So constant ra ang impulse ani nila, no? The impulse J is constant. And then, since time is large sa haystack, mugamay ang force para ma-remain constant tong J. Okay, so again, the same amount sa change sa momentum diri a class. Diba, impulse is equal to the change in momentum. So as you can see, the same ra ang change in momentum, meaning to say the same ang impulse. So gikan sa ang iyang momentum kay mv, mahimo siyang 0 kay mo stop man ni siya eventually. This one also mahimo po siyang 0 because this will stop eventually as it hits the concrete. Sorry. Okay. Now, ang nagmatter, ang nag-change is the amount of time. So, there is a haystack, ma-increase ang time of contact, thereby decreasing the force. So, gamay ra imong force nga magamay imong force. And then here, gamay kaayo ang time of contact. So, igo ra ni siya mo mubangga, tapos move siya pa backwards. Okay? So, the time of contact is so sudden, maong ang force kay so great that it will cause a very huge destruction. So, pwede ka mamatay. Okay? Another example is the same concept is used when kanang magbuak ka og something. Like, for example, a hollow block using your kamot. So, kabantay mo mga videos nga ing anak class. Magbuak sila og hollow blocks using their hand only. And ang ilang buhaton is, so pinakalit ra nila gina slice ang hollow block using their hand. All right, so let us continue. We have 16 minutes left. So taas pa kayo tag madiscusan. Okay, so momentum versus kinetic energy. All right. So as you can see, momentum is proportional to the velocity. So you have P is equal to M times V. So it is proportional. It is directly proportional to the velocity. So as you increase the velocity of the object, the momentum also increases. Whereas kinetic energy is also directly proportional to the square of the speed. So not the velocity, but the speed. Kinetic energy is a scalar quantity. It is proportional to the square of the speed. So if you also increase the speed of the object, then kinetic energy will also increase. So for example, if you double the speed of the object, kinetic energy will be quadrupled, okay, because it is directly proportional to the square of the speed. Now, you can relate momentum and kinetic energy. So, asa man ni siya gikan? I don't have my ball pen here, so let me try to. Okay, so recall that P is equal to, mv, okay? And then kinetic energy is equal to 1/2 mv squared, mv squared. Okay, now I will multiply m divided by m here. Okay, so you multiply yan siya na kog 1, but to do the trick, ang 1 is m over m. Okay, so this one, you have 1/2 m squared v squared, over m. I hope you can follow through this one. So now m squared v squared is equal to p squared, class. Sakto ba? When we square both sides, we will get m squared v squared equals p squared. So kini siya nga term diri as a numerator. This is actually equal to p squared. So you have p squared divided by, in the denominator, you have 2m. So this is how kinetic energy is related to the momentum. So you have Ke is equal to P squared over 2m. So what is their physical difference? Okay, so we have here a situation. Which is easier to catch? A 0.5 kilogram ball moving at 4 meters per second, or a 1 kilogram ball moving at 20 meters per second? Okay, so pwede mo mag-answer sa chat box, class. So which is easier to catch? A 0.5 kilogram ball moving at 4 meters per second, or a 0.1 kilogram ball moving at 20 meters per second? The 0.5 kilogram ball, why? Because
Mas hinay ang speed, ma'am.
0.5 kilogram ball because hinay ang speed. Mas bugat siya, mas gaan yung speed. Okay, so let us calculate their momentum. So, di ba, ang sa to? An object that has a very large momentum is difficult to stop. So, that is the reason why kung naakay option between magpaligis ka og ice cream og truck, of course, sa ice cream, ra gyud ka magpaligis, no? Kay gaan ra siya, tapos hinay ang speed. So, gamay siya og momentum. Ang truck, ako kay siya momentum, kay bugat siya, tapos ako pa dyan siya speed. So, ako dyan siya momentum. It is difficult to stop it. Okay, so let us solve their momentum. 0.5 times 4, that is, pila man siya, class? 2 kilogram meters per second. So, this one also, 2 kilogram meters per second. So, they have the same momentum. Okay, so, the momentum is not an issue. Kaya pareha man sila, but let us calculate their kinetic energy. So, can you help me calculate their kinetic energy? So, 0.5, 1/2 times 0.5 times v squared. So, 1/2 mv squared, you have 16, 1/4 sa 16 is 4. 4 joules ni siya. And then, kining isa, 0.1 times 0.5 times 20 squared. 20 squared is around 400 na siya, no? 20 squared. Yes, 400 times 0.1, 40 times 0.5, 20. So, kini siya, ang iyaang kinetic energy is 4 joules. This one, ang iyang kinetic energy is, pila to? 20
20,
joules.
ma'am.
Okay. So, this one is difficult to catch. Meaning 0.1 kilogram ball moving at 20 meters per second. Okay, na-notes diri akas. Both have the same momentum. Then both requires the same impulse for the ball to stop. But the kinetic energy of the 0.1 kilogram is much greater than the kinetic energy of 0.5 kilogram. Hence, more work is required to stop the 0.1 kilogram ball. Okay. So, nakuha ninyo?
Yes, ma'am.
Right? So, let us continue. So, the conservation of momentum. Now, take note of this. All types of collision, the momentum is conserved. So, in your laboratory, you have learned that there are two major types of collision. We have the elastic collision and the inelastic collision. And then under the inelastic collision, we have the perfectly inelastic collision. Okay, so in all those types of collision, the momentum is conserved. Okay, so what does it mean when the momentum is conserved? Okay, so we have here two balls that are colliding. So initially, ball 1 is moving with velocity v1, and ball 2 with mass m2 is moving at velocity v2. Okay, so take note that you need to set the direction of your object. So for example, imo siyang iset nga ang motion to the right is positive, ang motion to the left kay negative iyang speed. Okay, so you have for ball 1, iyang initial condition is this. M1 V1 iyang momentum. For ball number 2, M2 V2 iyang momentum. And then here comes the collision. At the final state, there will be changes in the velocities. Okay, so for ball 1, it will now be moving with velocity v prime 1 to the left. And then for ball number 2, it will be moving with a different velocity v prime 2 to the right. Okay? Now, the conservation of momentum states that when you add the momentum before the collision, it is just equal to the sum of the momentum of the objects after the collision. Okay, so that is the conservation of momentum. So P initial, the total momentum initial is just equivalent to the total momentum final. Okay. So in terms of the initial and the final momenta, you have P1 plus P2. So take note, class, that this is vector addition na po. Balik na po tag vector addition. It is equal to P final 1 plus P final 2. So the prime P represents final, or instead of prime class, you can use F and then I's diri. Okay, so from Newton's third law of motion, the law of action and reaction. So the force that the ball applies, the force that the balls apply to each other have equal magnitude but opposite in direction. So, bisan pa og bus ni siya og aninipot, so bus and firefly, they will have the same amount of force. Okay? So, the amount of force that they will exert on each other is equal in magnitude but opposite in direction. Okay? Now, from the impulse momentum theorem, we have your body 1. So, integral na ni siya, class. For body 1, the integral of the change in momentum is equal to the integral of f dt. Okay, so when we integrate this one, integral class is just like summation. So, mura kaga sum up. So, integral of f2 on 1 dt. Okay, so note that f2 on 1 is equal to negative f. Okay, so you have the integral of minus f dt. So this is for body 1. And then for body 2, you have p2 prime minus p2, or the initial momentum, the final momentum minus the initial momentum for body 2 is equal to the integral of f dt. Okay? So again, for body 1, the final momentum minus the initial momentum of body 1 is equal to the integral of negative f dt, while for body 2, it is equal to the integral of f dt. Okay, so equating these two, so kinino kung i-equate ni sila nimo duha, pareha naman ni sila, class, ibalhin lang nimo ang negative sign diri and equate this two. So you have integral of f dt is equal to integral of f dt, kini siya kay p2 prime minus p2, and then kini siya mahimo siyang negative. Okay, so you have this one, negative p1 prime minus p1 is equal to p2 prime minus p2. Okay. So this is exactly the conservation of momentum. So kung imo ni siyang i-manipulate, so P1 positive, balhin na to diri si P2, may mo siyang positive also. And then P2, ibalhin po ni siya na to sa right hand side, so you will get this one. So P1 plus P2 equals P1 prime plus P2 prime. So the left hand side of the equation is the initial momentum. This is before the collision. And then the right hand side is the final momentum, or after the collision. All right. So ato lang gi-derive ang conservation of momentum using the definition of impulse.
Mama, please.
Okay, so we have 1 minute left. So in the next meeting class, we will discuss the types of collision.